Thank you, Jan. Thank you for the nice introduction. I'm Antonio Martini. I'm associate professor at University of Oslo, and I work part-time at Chalmers University of Technology. And I also work with Software Center. I've been working with Software Center, I think, for several years now, probably 10 years. And this project is associated with the Software Center, meaning that we have the technical debt the technical debt project, but Saulo is a PhD student of mine, and he has been employed at the University of Oslo, so it's not directly funded by the Software Center, but we have been working together with the Software Center to present these results. So what you will see here, it will be a mix of some results that comes from the Software Center and some results that we have obtained also with other companies that are not in the Software Center. We will not do any mention or any discerning during the presentation. Just know that some of the companies are from the Software Centers, others are not. Saulo is third year of PhD, and he will defend soon. So here he will present a few very interesting results that we have been collecting during the latest 3 years in this project. Okay, so that said, I think I will just leave the floor to Saulo to go through these very interesting results. So Saulo, please.
Okay, thank you. As Antonio said, my name is Saulo, and I think you already introduced my work at the University of Oslo. And the topic of this presentation is microdebts and microservices. And it's just an idea about the most costly technical debt, architectural technical debt that you had on microservices architecture. And we'll briefly discuss about how to understand and managing them. So I'll start right away with the presentation. So a quick overview on microservices. So microservices is an architectural style. The idea is to separate your application into small services. These small services have their own focus tasks. They are focusing on small things, on simple things, and you have these services together to build your solution. Each microservice should have their own database and work in there as a small application. And microservices are often compared to monoliths. A monolithic software is that software in which you have everything in the same piece, in the same place, in the same deploy. You have the user interface, the business layer, the data access layer, everything in the same place. So microservices is a distributed architecture. It's important to mention that microservices compared to monoliths are very, very small. So you have really small services focused on one task only, and monoliths you have everything in the same place. So the databases and microservices are smaller, the services are smaller, and so on. The whole idea is to have services focused, for example, one service for payments, another for statistics, another for users, and so on, and put all the services to work together to build your solution. On the other hand, we have technical debt. Companies, every company has technical debt. So do we as companies have technical debt? Yes, it's everywhere, right? And technical debt, it's sometimes it's nice because you can do things that you could not do before. For example, if you don't have money to buy your house today, you just go to the bank, you get a loan that it's a debt, and you can buy it right away, right? So there is a good thing on technical debt, but people tend to think about that. Sometimes I'm as the bag of gifts from Santa, right? In which everything is good, so we can do things right. We can speed up everything, and yeah, but that's not really true. The important part, it's important to notice that there is an interest here, and this interest is it's increasing our costs, right? So to make it clear, technical debt consists of suboptimal solutions. The solutions deliver benefits in the short term, so it speeds up things now, but increase the overall costs in the long run. And we will talk here about one specific type of technical debt, that is the architectural technical debt. That is the same concept, but in architectural decisions, architectural solutions. When you talk about technical debt, we have two concepts that are important to understand. One is the interest. Interest is the cost is the extra cost you are paying for the debt. So, for example, in the example of the loan, you get a loan for the bank, but you have the interest. You have an extra cost to pay for the bank. And the principal is the cost of doing this solution right away or fixing the solution, right? So it's the cost of doing the right thing. So you can put those things in a balance in a place, and you can measure those things. And if the interest is too big, is bigger than the cost of doing things right away, correctly, it's better to pay the principal. On the other hand, sometimes the principal is too costly. You have, for example, a startup, or it's a software that you want to test it right away, and you need to see if it will work or not. So if you wait too long, it will not work. So sometimes, in this case, the cost of the principal is too high, so you can get the interest. So managing technical debt is keeping things simple, is measuring those things and having a decision here. What is better for you now? But okay, what is technical debt in the microservices architecture, right? That's our question. So to answer this, we had three main researches here, three pieces. And the first research, and we went to companies and asked about technical debt in microservices. These companies were using microservices architecture for a long time, and we identified the most common ATDs and the most dangerous and the most costly technical debt. And then we went to other companies and investigated the prioritization. How do they prioritize technical debt? Okay, now we know what's technical debt, what technical debt we have from other companies. How do we prioritize? So we did an investigation on prioritization. And one last study, we went to a single company and we measured. We actually did some measurement in technical debt for this single case study. So this is an overview of what we will present to you right now. Our first research was with 7 large companies. These companies were working with microservices for a long time. And we had interviews with practitioners, and these companies had distinct application domains. To give you an overview of the companies involved in this study, I can show you this table here. So we had companies from finance, cloud, IoT, health services, public services, transport. And you can see here quickly an overview. They were pretty large companies with a lot of people involved in the services. At least we had from 40 to 3,000 services, so it's pretty diverse. So the 3,000 services is a pretty big system, but 40 microservices is not also, it's not so small. It's also considerably big, and from some systems working from 1.5 years to 10 years old. So that was the situation. The companies we investigated, and we created a table with 12 debts, actually 16 if you consider the sub debts that are detailed in the paper. And we found that some technical debt are everywhere. Some others are costly, but are specific to some cases. As in this example here, you see that some debts were only for 2 companies. Others, for example, ATD7 was everywhere with all of them, right? So a brief overview of the debts. For example, microservice coupling. We had coupling on coupling is it's hard to avoid coupling, but there are ways, for example, how do you plan the microservices? How do you separate the microservices that you can try to avoid this coupling or at least mitigating it? Misusing shared libraries. Shared libraries is common, especially in people that are migrating from monoliths to microservices. And there is some, you need to keep control of this. Sharing persistence, insufficient metadata, poor API design, these are all things that are costly to companies, especially in large services. And the cost of these debts, well, we have an extensive list of costs, but for example, management overhead, dependency among teams. So the idea in microservices is that you have small teams, each team working in their own microservice, and they can work, they do not have dependencies. They should not have dependencies, so they could work independently. But some of this technical debt can lead you to have dependencies among these teams, and this is not desirable. This is something you should avoid, and that might be costly because you have teams waiting for other teams. Potential breaks, instance, decreased team velocity, issues that are visible to users, difficulty to provide new features, and the list goes on. So these debt are costly, and depending of the situation, that can be really macro, it can be really big, right? And you need to work on this to avoid these debts. In our paper, we also have something that might be interesting for you. It's a map in which we connected. Of course, this describes the context of the 7 involved companies, but we created a quick map in which we connect the debt, the interest, and the principal, and the solutions and the consequences, right? A brief example, just a small example from this. You can see the details in the paper, but for example, the coupling causes management overhead, causes dependency among teams, among other things. And we can see that inadequate use of APIs, when you, for example, is also connected to dependency among teams. So if you see that in your company that your teams, you have dependencies among teams, you can start looking at this on this, that's to see if they, you can try to mitigate it. And after this study in which we identified technical debt, that you have this catalog of debts and the solutions that the companies had and the costs that they also had, right? We visited 3 other companies, and these 3 other companies were slightly different. They were migrating from a monolith architecture to microservices architecture. And in the past, they had this monolithic architecture. Just a quick thing. From this, we had 47 participants from these 3 companies involved in this study. Okay, so they are currently in a sort of in an initial microservices architecture. They had this. They still have the monolith that is working. It's being migrated piece by piece, and they started to have some microservices. So it's something in between, right? But their goal in the future is having a full microservices architecture. So we asked them, what is the most costly technical debt? And we asked them to prioritize the technical debt, right? And the final prioritization we had is that coupling is on the top. So we see that coupling is something that everyone is having. Maybe they do not pay enough attention in the beginning. Maybe they try to, but because of other things, they don't manage to mitigate this. And we noticed that microservice coupling, at least for just 3 companies, they are always on the top. It's always worrying. And we had other things, for example, the unplanned data sharing and synchronizations, because in microservices, in the monolith you have one database. In microservices you have small databases, and you have to synchronize these databases, and this is sort of challenging somehow. And we have other things in this prioritization. it's important to mention that the prioritization is different for distinct companies. But despite things like, for example, microservices tend to go to the top for everyone, but the whole prioritization is different. It's important that you manage the technical debt and you see this, you repeat this in your own company to identify what is the most costly technical debt for you and which debts should you try to mitigate and resolve. So basically you need to first understand, read about the debts, the possible debts, right? So you have an idea about where to start. Then discuss these debts with your team to prioritize so you can see what is being more costly for us, for your company. And then you must keep track of this debt and assess this from time to time to see if the cost increased, and if you should change your prioritization. And we stopped here and we went to another company, a single case, in which we investigated instance as the cost of technical debt. Of course, the interest of technical debt can come in management overhead, like we said before, right? Development overhead, so it's different from management overhead. So you have a lot of things to look at, right? In this case, we focused on instance and the happening of instance that they had, and before and after migration from a microservices architecture. I will show you quickly how this works. But this company was a financial sector with 1,000 microservices, 150 of which were business critical. So what was their situation? They had an old microservice architecture, so it was already on microservices, but they had instance. And they refactored this microservice architecture by removing technical debt, by repaying the technical debt, and they avoided some instance. And we investigated the impacts of this refactory about this managing. They managed the technical debt, they removed it, repaid, and we investigated before and after. Our results, you can see here, it's the full results table. But I would like you to pay attention with one thing. See, there's kind of instance, the crashes and queueful errors that are a specific kind of instance that they had from the company inside the project were completely removed. So you can see in the total column, in the end, the final total column, that the previous architecture, they had 2,900 instances, and after refactoring it, they had 471 instances only. So it's a huge reduction, and they removed costly technical debt that was on crashes. For example, a crash, the system stops working, right? So they managed to remove this kind of instance completely. So it's important to manage technical debt. It's important to repay, to investigate, to keep track of them, and from time to time do this kind of things. Otherwise, your system might become impossible to manage, impossible to work on. Another huge result here. So these companies, they had this what they called critical priority instance, and the critical priority instance is that kind of instance that just stops your company from top to bottom, right? So your company stops working for some time. That might be minutes, but depending on your business, that can be quite costly for you, right? And after this refactoring, they managed to reduce from 8 to 1. So one thing here is the new architecture, it's for them, it's everything that's good, everything works right now, but it's important to mention that they did not manage to reduce this to 0. They had at least 1. So it's important to continuously manage technical debt because you will always have that, and you will always have some cost coming from it. But it's important to manage. So reducing from 8 to 1, it's a huge thing, right? Because each critical priority instance is very costly. And the same happens with high priority instance. They are smaller than critical, but they are also pretty big. And they reduce it from 33 to 3. But okay, we have these cases, but how to manage technical debt in your company? What should you do, right? So first you need to identify technical debt in your company. That can be made with help of tools or not. That needs to be this needs to be done from time to time. You need to know what is, because technical debt is initially invisible. You don't see it, so you have to identify them. After identifying this technical debt, you have to keep track of this technical debt. You need to put this in a tool, in a backlog, somewhere in which you can assess and see it, right? And after this, you need to quantify and prioritize. So, and we developed a method for this, for quantifying and prioritize technical debt. If you want to know more about it, you can keep in contact with us later on. But you need to quantify this, because quantifying, to some extent, maybe it's hard. Some things are hard to quantify, but you can have an idea. And you should prioritize and say, okay, these 3 in the top, we should assess first. We should try to repay it first. And of course, repay this technical debt, because, and this keeps going on. You have to do everything again from time to time, and because new debts may appear, and you need to prioritize things and identify and go on. So, as conclusions here, we also found that our specific technical debt to microservice architecture. So every type of architecture has this own types of technical debt, and this debts might get costly, or what we call here macro, between quotes, right? In quotes, this debts may be costly, and so it's important to repay them before they become too difficult to repay. You have to assess them in time, and you need to have this from time to time, right? Instance might be one cause of this, but not only. And technical debt depends on the context of the companies. So you need to access for your company, and must be managed timely, right? So we have developed methods to quantify and prioritize this, and yeah, we can also discuss more details. It's difficult to do it in this short presentation, but that's all I have for now. And if you can also always contact us to discuss this in more details, and I'm also open to questions.